Multiplying fractions. When we multiply fractions, we don't need a common denominator. But what we can do is simplify before we multiply. If you have common factors that are in the top and the same common factor is in the bottom, you can reduce it out by dividing each number by that common factor. So in this case, I see that I have a common factor of 5. In 5, 5 goes into 5 once, and that 5 will also come out of 15, and I'll be left with 3. I also can simplify that 4 and that 8, and I end up having it simplified to 1 and then the 2. Once it's in simplest form, to multiply, you're going to multiply across. So you multiply the numerator to numerator, and in this case I have 1 times 1, and I'm going to get 1, and then denominator to denominator, so I end up getting 2 times 3, which is 6. So multiplying fractions, you want to simplify first, and then you're going to multiply across. Pause and try. So in this case, you see that 3 is going to go into 3 once, 3 goes into 30 10 times, and then you have 8 goes into 8 once, and 8 goes into 32 4 times. Now that it's simplified, I can multiply across. 1 times 1 is 1, 4 times 10 is 40, and I have my multiplied fractions. Pause and try. So I'm going to simplify here. 5 goes into 5 once, 5 goes into 15 3 times, 3 goes into 3 once, 3 goes into 12 4 times. Now be careful here because we have a positive times a negative. So when we multiply across, we're going to end up with a negative 4 over 3. So it's very important that you also incorporate the rules with signs. So when you're multiplying a fraction with a whole number, you always want to deal with fraction to fraction. So remember that property of 1 rule states that you can make that whole number a fraction by putting it over 1. So we're going to put that whole number 16 over 1, and now we can multiply. So when you multiply, you want to simplify first. 16 goes into 16 once, 16 goes into 36 twice. You multiply across here, we end up with 5 over 2. Pause and try. I'm putting that 18 over 1. I'm going to simplify that 9 goes into 9 once, 9 goes into 18 twice. I'm going to multiply across, and you should have gotten 16 over 1, but you can't leave 16 over 1 because you always have to have it in simplest form. So your final answer would equal 16. Pause and try. I'm putting that negative 8 over 1. I'm going to simplify here. Don't lose that negative sign. You're going to end up with a negative 3 over 2. So now I want to talk about the definition of what a reciprocal is. A reciprocal are two numbers are reciprocals if their product is 1. So when you multiply two numbers together and it equals 1, then they are reciprocals of each other. So if you notice here, I have 3 over 4 times 4 over 3. When I multiply these two fractions together, you notice that when I simplify, I'm going to end up having 1 over 1, which equals 1. So what that means is 3 over 4 and 4 over 3 are reciprocals of each other. So when you're looking for a reciprocal, you can find the reciprocal by flipping the fraction over. So 3 over 4, when I flip it, I end up with 4 over 3. And when you multiply them together, you end up getting a 1. So this is the definition of what reciprocals are. So when we're working with division of fractions, it's important to understand reciprocals. Now, when you do division, you're going to take the reciprocal of the second fraction. So you're going to keep the first fraction, you're going to change the division symbol to multiplication, and then you're going to get the reciprocal, or you're going to flip the second fraction. So with division, you're going to have to set up your problem to be a multiplication problem in order to do the arithmetic. So keep the first fraction, change the division to multiplication, and get the reciprocal or flip the second fraction. Now that you have it set up, you can do the arithmetic. You're going to have to simplify here first. Now I'm going to simplify, and with the 18 and the 15, I see that they have a common factor of 3. So I divide 18 by 3, I get 6. I divide the 15 by 3, and I get 5. Now with the 7 and 14, 7 goes into 7 once, and 7 goes into 14 twice. Now that it's in simplest form, you're going to multiply the top to the top and the bottom to the bottom. 6 times 2 is 12. 1 times 5 is 5. So you end up with 12 over 5. Pause and try. So you're going to set it up first by keeping the first fraction, changing it to multiplication, and getting the reciprocal of the second fraction. But don't lose the signs. Signs are important. Now we're going to simplify here. 7 goes into 7 once, 7 goes into 14 twice, and you're going to multiply across. Don't lose your negative sign. Positive times a negative is going to end up being a negative. 5 times 1 is 5. 2 times 3 is 6. So you end up with a negative 5 over 6 as your solution. Pause and try. So you're going to set it up, keep the first fraction, change it to multiplication, and then get the reciprocal of the second fraction. Simplify and then multiply across. So you should have gotten 9 over 8. This next example is when we have division of a fraction by a whole number. Whenever you're working with whole numbers, you want to make it a fraction. You want to work with fraction to fraction. So that whole number you're going to put over 1. Now you have fraction to fraction, and now we can work with the division problem. Remember, keep the first fraction, change it to multiplication, and get the reciprocal of the second fraction. So here you see, if you did not put that 8 over 1, you wouldn't have flipped it to get 1 over 8. So it's very important that you work with whole numbers to put it over 1 so that you have fraction to fraction. And now you're going to simplify and you're going to multiply across. So you should get your answer to be 2 over 25. Pause and try. So you're going to put that whole number over 1. You're going to keep the first fraction. You're going to change it to multiplication and flip the second fraction. Simplify, and then you're going to multiply across. So you should have gotten 2 over 7. Pause and try. So notice here that the whole number is in the first spot. We still need to put it over 1, but we're going to keep that the same. You're going to change it to multiplication, and you're going to get the reciprocal of the second fraction. Now you want to simplify here. You're going to simplify by dividing 4 out of 8 and 4 out of 12. So you end up with 2 and 3. Now, don't lose the sign. We have a negative times a positive, so it's going to be a negative. 2 times 5 is 10. 1 times 3 is 3, so we end up with a negative 10 over 3. So this next example, we have multiplication. And notice that we also have variables, that variable x. We have it in the denominator and we have it in the numerator. So when you're multiplying fractions, you want to simplify first. We're going to simplify the numerical part. 7 goes into 7 once. 7 goes into 21 3 times. And then notice you have an x on the top and you have an x on the bottom. Because they are the same variable, it means it's the same number. So that can be canceled. So they cancel out. Now you're going to multiply across. 1 times 4 is going to be 4. 15 times 3 will end up being 45. So we end up getting 4 over 45 as our solution. The variable was canceled out. Pause and try. Okay, you're going to simplify here. 2 goes into 8 4 times. 2 goes into 14 7 times. Notice the variables cancel. And then I have 3 goes into 15 3 times. 3 goes into 27 9 times. Now I'm going to multiply across. 4 times 5 is 20. 9 times 7 is 63. Pause and try. Keep the first. Change it to multiplication and get the reciprocal of the second fraction. So always be aware of what operation's going on. Division, you're going to have to set it up before you start simplifying. Now I can simplify. And in this case, 2 goes into 8 and 2 goes into 6 3 times. The variable x will be canceled out. 5 goes into 5 once. 5 goes into 15 3 times. But notice here that y variable does not get canceled out. So in my solution, I'm going to have 4 times 1 is 4, and then I'm going to have 3 times 3 is 9 times that y. So I end up with 4 over 9y as my solution. So now working with complex fractions. Complex fraction is a fraction with another fraction in the numerator or in the denominator. So notice here that this is a complex fraction. I have a fraction on top and a fraction on the bottom. Well, remember that a complex fraction or a fraction is really a division problem. So really what I have is the top fraction being divided by the bottom fraction. 5/6 is being divided by 2/3. So complex fractions are really just division of fractions. So if you set it up as a division of fraction problem, you'll know how to do the operation. So I end up doing the 5 over 6 divided by 2 over 3, and you're going to have to keep the first fraction, change it to multiplication, and get the reciprocal of the second fraction. Simplify and then multiply across. So complex fractions turn into division of fractions, and then you're going to have to set it up and do the arithmetic. Pause and try. It's 2/9 being divided by 5 over 12. I need to set it up. I end up with 2/9 times 12 over 5. I'm going to simplify here, and then I'm going to multiply across, and then you should have gotten 8 over 15. This next example, you're going to notice that we have the distributive property. Now remember, the distributive property is when we have an algebraic expression inside the parentheses with something on the outside attached. In this case, you see what's attached on the outside of the parentheses is a fraction. So that fraction is going to be multiplied to everything inside the parentheses. So when we do this distributive property, I'm going to end up taking that 2/9 and multiplying it to everything inside. So I'm just going to do the first piece first. I have 2/9 times 9n squared. Now I want to do this multiplication and have a fraction times a whole number. Put that whole number over 1. Now you can simplify. I'm going to simplify. The 9 will cancel. I multiply across, and I'm going to end up with 2 times 1 times n squared. So we end up with 2n squared when I do the distributive property. I'm going to do it to the next piece. I'm going to end up having minus 2/9 times 27n. I'm going to put that 27 over 1. I'm going to simplify, and then I'm going to multiply, and I'm going to end up getting a minus 6n. I do it to the last part, so I end up getting plus 2/9 times 18. I put the 18 over 1. I simplify and I multiply and I end up getting a plus 4. So when you have the distributive property with the fraction, keep in mind how to work with fractions and whole numbers. So your answer here, when you do the distributive property, will end up being 2n squared minus 6n plus 4. Pause and try. We're doing the distributive property. You want to make sure that that whole number goes over 1. Simplify piece by piece. You're going to end up with 15n squared. And then I simplify the next piece. I'm going to end up with minus 6n. And I simplify that last piece, and I'm going to end up with plus 9.